We can again have a product and a chain rule. So the chain rule embedded inside the product. However, we could also rewrite this cotan. So I'm not a big fan of cotan, so I'm going to rewrite it as tan in the denominator. And we may get a different looking expression, but they are equivalent expressions. So here we're going to end up with e to the root sine x. So we have an embedded root, an embedded sine, and that's going to be over tan x, and then I'm going to apply the quotient rule. So f prime of x, now again, you don't need to use a quotient rule. If you prefer using the product rule, you can use a product rule with cotan. But I'm going to use the quotient rule here, so I'm going to differentiate the numerator, and I'll do the numerator in different colors. So I'm going to end up with e root sine x times 1 over 2 root sine x. I'm differentiating the e. I go differentiate the square root, and then I differentiate the sine. Okay, so there's my product, or sorry, there's my chain rule for the numerator. And then multiplying by the denominator minus e to the root sine x. Okay, nothing changes there. Now I differentiate the denominator into secant squared x, and then that's all over tan squared x. Okay, so there's my derivative. Again, I could try to simplify some of this. Really, the only thing I can simplify is the common factor of e to the sine x. I'm just going to clean it up a little bit. Okay, just make it easier to work with if I need to calculate a derivative or a slope. Okay, so I'm going to factor that out. I end up with e to the, so this is going to be cos x over 2 root sine x tan x minus secant squared x. Okay, I don't see any obvious identities, and that's all over tan squared x. Okay, so same thing here. We're going to apply the quotient rule, but when we differentiate the denominator, we're going to have to apply chain rule. So when I differentiate this, I'm going to end up with the derivative of the top, cos x, times the denominator. Okay, the denominator doesn't change, minus, I'm going to differentiate I'm going to leave the sine x by itself. Now when I differentiate the denominator, I need to make sure I apply chain rule. So differentiate the e, differentiate the square root, and then differentiate the x squared. So that represents the derivative of the denominator. Okay, and then again, we just square the denominator. Okay, so I put the squared into the exponent. So again, we can probably simplify this. There's some simplification that we can go use. The 2's can cancel here. Okay, and we probably can factor out the e to the x. Okay, however, we don't have to simplify this if we're using this for derivatives. It is a good habit to get into to simplify expressions, because the more complicated your expressions are, the more likely you are to make some algebraic error. Okay, so here we're going to end up with sine x sine x over square root x squared minus 4. Okay, and in this case, we can cancel out common factors and make this even a little bit easier to work with. So we end up with cos x minus, and just double checking this, I have sine x times x in the numerator and the denominator, yeah. So x sine x over square root x squared minus 4, and then this just becomes e to the root x squared minus 4. Okay, and again here my derivative is here, although I can simplify it to this expression.